Okay, yesterday when we looked at the fundamental counting principle, we did an example where we had letters, we had to rearrange different letters in a word. So like for example, we looked at the word Leduc and we said by using fundamental counting, we have 5 choices for the first letter, then 4, 3, 2, 1. So we could just multiply all of our choices and we got an answer of 120. So that works pretty good like that, but what would happen? So what would happen if we had a word that had like 10 letters in it? So if we had a word like, I don't know, British Columbia or something like that. So we have a whole bunch of letters. Then you'd have to go 10 times 9 times 8 times 7 and so on. Or what happens if we had a word that had like 20 letters? So you could still use fundamental counting, but you can see it's going to take you lots of time to type all those in on your calculator to actually figure out the answer. So in math, we have a notation that's called factorial notation, and it works handy for these kind of questions. And what it does, so what factorial does is it helps you do these calculations a lot faster instead of going 5 times 4 times 3 times 2 times 1. So what you do is on your calculator you find the factorial button and it looks like an exclamation mark. So you just use 5 exclamation mark, that means 5, 4, 3, 2, 1. And so if we had a question where it was 10, 9, 8, 7, 6 all the way down, you would type that in as 10 factorial. So on the TI-83 calculator, or 84, whichever, how to get to it is you got to hit the math button. So you go to math, then you have to scroll over to probability. So at the very top it has a whole bunch of different choices. So you got to scroll all the way over to the far right, hit probability, and then after that you choose number 4 factorial. Okay, so it's a little bit of a hassle. You got to, if you were to try to figure out 10 factorial, you got to type in 10, and then go math, probability, factorial. That'll give you the button, and then hit equals and it'll give you the answer from that. Other calculators, like usually just regular scientific calculators, you can just, there should be a factorial button. Usually it's a shift button that you have to pick. Or if you use the My Script calculator, you can just draw in the factorial symbol and it should be able to know what to do with it. Okay, so factorials are a pretty good way of speeding things up a little bit, and with factorials we've got to remember that it actually can be written a few different ways. So if I had 6 factorial, that's 6, 5, 4, 3, 2, 1 all the way down. But if I did 6 times 5 factorial, that's going to be basically the exact same thing, because it would be 6 times, and then 5 factorial would be 5, 4, 3, 2, 1. Okay, so you'd have the exact same answer. It's still going to be 120 or 720, I think it is. If I did 6 times 5 times 4 factorial, you can see that those would also be the same, because now it's going to be 6 times 5 is our regular numbers, and then 4 factorial would be 4, 3, 2, 1. So you can always break up the factorial into sort of smaller components, and you'd get the exact same answer. It also works the same if you were dividing. So if I said I want to divide 6 factorial divided by 4 factorial, you can see that we'd have 6, 5, 4, 3, 2, 1 on the top. I'm just going to use dots because it's a little bit faster to write. So 6, 5, 4, 3, 2, 1 on the top, and then on the bottom, 4 factorial, you'd have 4, 3, 2, 1. Because we're dividing, you can see that those ones would cancel. So 6 factorial over 4 factorial then would be just the 6 times 5, which would give us 30. Okay? So with factorial, there's a few little tricks that you can always do. If you do, let's suppose I gave you another one kind of like that last one. Let's suppose we had 10 factorial divided by 7 factorial. You can simplify these without using your calculator, or you can do a lot of the work in your head. Just think of it as 10, 9, 8, 7 factorial, right? 10, 9, 8, and then the rest would be 7 factorial. And then on the bottom we got 7 factorial. So you can see our final answer then would just be 10 times 9 times 8, which would be 720. So you can always simplify these, even if you get one that's a little more complicated. So let's suppose I gave you 8 factorial over 5 and 3 factorial. Okay, so if we try simplifying that, at the top we can go 8 times 7 times 6 times 5 factorial. We'll just leave it as 5, 4, 3, 2, 1. Then on the bottom we got 5 factorial and 3 factorial. So now you can see the 5's would cancel, so the 5, 4, 3, 2, 1 would cancel. And we can even simplify this a little bit further, because 3 factorial is actually 3 times 2 times 1, which is 6. So we can actually cancel the 6 out as well. So in this case it would just be 8 times 7, which would be 56. So you can always simplify these without having to use your calculator, or you can just use your calculator as well. The other kind of question you got to be careful with factorial is what happens if they just give you a algebra letter instead of a number. So something like n factorial. So if we think of 10 factorial, that was 10 times 9 times 8 and so on. So using the same logic, n factorial then would be n. We'd start with the number n, then we'd times it by whatever n minus 1 is, right? Because that's how we got to 9. We subtracted 1. Then we subtracted 2 for the 8, and so on. And that would continue until you got down to 3, 2, 1, just like we do for normal numbers, right? In 10 factorial, we go 10, 9, 8, all the way down to 3, 2, 1. So it would be the same sort of pattern if it was n. So if I gave you a question like n factorial divided by n minus 1 factorial, you can see that this would be n times n minus 1 times n minus 2 and so on. And then on the bottom we'd have n minus 1 factorial would be n minus 1 times n minus 2 and so on. So you can see here all of those would cancel. So our final answer would just be the n left over. So if you do get algebra, they are a little more complicated, but you can always do them the same. So that's it for factorial. What we're going to do is we're going to look at permutations next. So I'll do that in a new lesson.